Okay, so we are here's another videos about data analysis after you like have your hard work done, your digestions, and finally after all the waiting on the queue, you get your data, and then like two things you can do before like after you start your peaks analysis, and like or like you can do the like quality analysis of your raw data, just make sure everything is okay before or after you do the peaks analysis. I usually like to do it after I do the peaks analysis because like just cue it up first, and if it's a problem I know it's bad, then I'll cue it. But um but anyway, before you get your data out of peaks, you need to do the quality control just to see like if all the files are running fine. So what you're going to do is you're going to like you already have your files download, and if you're using FreeStyle, well, sorry, you're using Orbi to like get your MSNet data. You use FreeStyle to check it. So this is FreeStyle. So you'll come into FreeStyle. Well, let me just close this, start from beginning. So you come into the FreeStyle, and just a warning that FreeStyle takes a long time to think. So it is really time-consuming process a little bit, especially if it is running another analysis on peaks. So go to where your files are. Like I say, it takes some time. And select one of the files that you want to look at. Start from one first. Okay, so you open the files. And it brings up of some of the view here. So just this is your mass bed file. It has like these are two dimension files. Your intensity here, and it is your retention time there. So, and this is your spectrum. So if you like put your mouse here and start like walking through like use the right arrow key on the keyboard, then you can see the spectrum is changing. Like this is at MS1 is one MS1 spectrum, and you can see it is at like 53 minutes, and it's at this time. And then that is like the signal of the MS1 is e to the 9, and like this is M over Z versus relative intensity. And then if you zoom in, you can see it is really abundant here. It tells you the M over Z, and it looks like a pretty isotope envelope. And then if you go to display options, like you click on spectrum, so it's highlighted in like this one highlight in blue, while other is like light blue. So you can go to this like it said like spectrum here, display option, you can like select its charge stage. So it is a charge 2. Okay, and you can also change it to like absolute intensity. Here's something I like to do, and you can continue walk. And it is an MS2. It looks like it is zooming. Yeah, okay. So now it's not zooming. Oh yeah, it was because I'm zooming to the MS1. So this like full spectrum from 200 to like we select from 180 to like 1350. That's your MS scan M over Z scan range. Okay, so that is an MS2 spectrum, and it's like precursor is like 669. So if you go back to is MS like 669. It's here somewhere. You have to zoom in. Sorry, 669. Somewhere here. Wait, or maybe it is the MS1 after. Let's see. It's interesting. Okay. But anyway, it tells you that that is your precursor mass, and that is like from that precursor, you blast off that precursor and you get this MS2. Okay, so this is just explaining like what you're looking at here. But when you're doing the quality control, you're going to like for most of a lot of our experiments here in the lab, no matter is like turnover rate or folding, you want like what you want to see beside your signal intensity. Okay, well I'm jumping. So let's do if you're looking at single fibers, what you want to see is you want to look at your TIC, your total signal intensity, and you want it to be at a reasonable amount. So like e to the 11 is a bit too high. So what you want to see is at like high 9 and low 10 range. But also like this is zero. And the other thing you want to look at the feature of your spectrum, like or chromatography. I see if that is something looks normal. So this is like this set is a good data set really. So I don't have something to tell you it is bad, but I like to change it to absolute because like really like for serums we know it is like dominated by serum albumin. So it is reasonable like for some retention time you might have huge signal. And like what really something like the less abundant trace amount of protein like might be at this like noise range. Really we don't have may not have a distinguished peaks. But like you want to look at like most of your stuff, my stuff is at like okay like 2e to the 10 range, so it's a pretty good descent. And you don't want to see polymer and like you want to see like a lot of spike in your chromatography, and but you also don't want to see a like polymer or like if you see nothing in the front, that is something that you should be worried. Okay, so like polymer samples and like what is something look weird, just like talk to your mentor, and when it comes to your like come to it happens, you'll know that that is weird. Okay, but the other things we're going to do in our lab a lot is we're going to compare the retention time between samples, because no matter like turnover rate, if you want to go into like your like data need to go into deuterator, it has to be like we have to have make sure the retention time shift is not huge. And on RB data, things like sometimes when you're running your samples on different calling analytical calling, it can cause you have different elution time like between steps. So that's like try to like you have to make sure your run is run on like if you're going to analyze them together, make sure they're running back to back and randomized. Okay, so here I have 9 samples. I'm going to just like to select display here and go here to select your samples. I'm going to do the order from 0 to 6. The other next one is 0.75 and then 1.5, and then just repeatedly do this until you get all the samples there up. 1.5, 2.25, 3, and 3.75, 4.5, 5.25, and 6. Okay, so now I have everything open on like 0 0.7, 1.5, 2.25, 3, 3.75, 4.5, 5.25, and 6. So all my files are up. I'm going to just like make it smaller here, and I don't need the spectrum list really. So here is all the 9 files. Like you're probably not going to see it really clear. So what you're looking at is this maybe major retention time shift on some of features like stands out feature. And what I'm looking at is actually like okay, you can see like between different samples, you can see like they have similar feature like starting low and have some like 3 peaks in the middles, and then I'm going to, hey, come on, I don't need you right here. Okay, well, it's not going away. And then like smaller peaks here, and at the end you have a huge peak when it's hydro, like really hydrophobic. So that is like the same feature. It is good. That is like for this set of sample. Okay, well, and also you want to look at like the like PIC for each one is about the same. So it's all at like 1e to the 11 range. That is good. And for this sample, like majority of them are okay. But if you're looking at like there's like 57 picks here, it's a little bit more than the others. That's interesting. And then if you look at here, that is like the like 3 peaks here. Like you can see 44 minutes, 45, 43, and then some are at 42. So the retention time is a little bit like bigger than what I anticipate, but like within 3 minutes each is still a acceptable range. So I think like it is not a major problem, like something that like go completely wrong, like for this run. But if we notice like if there's like data doesn't quite speak out, then we might know why. It's just really interesting. And you can also see the traits here at the end is a little bit shifted. Like you can see this one is like approximately the same traits here, but it's either more spread out or they're more squeezed. I'm not sure. So we'll have to let the data speak to us. But this is a first assessment, like you're going to have just eyeball if the retention time have any things like any major problem of your samples. Just saying, if like now if this peaks like this 45 peak is shifted to 55, then you know, okay, well they like you might need to skip these samples for your voting, like for your full curves, because like it is just not going to be good. Or the CHAF should also exclude that, might also exclude that data for you. So if you come here and copy to the clipboard and then open the Excel files, you can paste it and then you can actually then save it somewhere. I like to do it in download for now, just now. Just for me, I have a hard disk like there on the computer. So, well, I think I actually have another files already for this set of data. But I just do it here and then, yeah, okay. I already have one, so I'm going to open the files and then save it as like I have like E0 already. So this is like E200. So just save it like you can print it to your notebook to put it in your notebook or just save it in your files to make sure you have that saved and available for you. Okay, so that is like basic quality control you're going to do. Okay, I'm going to stop here and start another video for our next one.